So we're starting chapter 5, and the first section in chapter 5 is all about exponential functions and their graphs. So when we're looking at an exponential function, we're really looking at something that's f of x equals a, some number a, to the power of x. A needs to be some number greater than 0, and x has to be any real number. So one thing that you should pay attention to that is a is not equal to 1 in this situation, because 1 to any power is always going to be 1. So it can be any number greater than 0, but not 1 is the one exception. So let's look at a couple of examples. Here you're supposed to use a calculator to find these. So you're going to put into the calculator 2 to the power of negative 3.1. I just want to look at how it looks on a keystroke. Notice that it is using this hat symbol or caret symbol. So on your calculator, you'll be using that. If you're using Desmos, there is also, I think it's this symbol. Sometimes you'll find on a calculator, it'll look like x to the y. You might use that. Okay. So on all three of these, you are using a calculator to solve them. And here are some examples of what the keystrokes would be. Let's look at some graphs. These are two different graphs, 2 to the x and 4 to the x. Notice that they use a t-chart, and in your homework for today, you're going to also use a t-chart where you'll plug it in to a calculator and write it out. And then they plotted the different points. Notice that y to the 4x is a lot more steep than y to the 2x. So the higher the a value, the greater the a value, the more steep that incline is going to be. Some other little points that you should note is notice that there is an asymptote here, even though you can't really see it because it's invisible. There's an asymptote here. It never crosses the 0, the y equals 0 value. And it always has an intercept here at 0, 1. So when you're thinking about this, the domain has to be, it goes from negative infinity to positive infinity, because every x value is possible, but the range is only possible from 0 and up, not including 0. It's an increasing function from left to right, and it's continuous. Sometimes it might go in the reverse order, and that is because either x is negative or a is a fraction. So for instance, you could say 3 to the negative x. If you think about what that really means, it means 1/3 to the x, because anything to the negative power puts it into a fraction form. So both of these mean the same thing. Thus, this means the same as this. So if it's in a fraction form, if a is a fraction, and it's less than 1, by the way, and actually this should be a less than 1, not greater than 1, then it's going to be a decreasing type of exponential value. Notice the last one, it was always increasing. This one is always decreasing. The domain, again, is the same thing, going from negative infinity to positive infinity. Every x is possible. The range, however, there is an asymptote here, just like the last one, and it still has a y-intercept of 1, and it's continuous. There is a special case of an exponential function, and that is natural base e. So e is a special irrational number, 2.718, and so on. It's called the natural base, and it is a special exponential e to the x, as you can see here. And you will calculate it the same kind of way if you're going to put it in your calculator. If 2 Negative 2 is your x value. Put e to the power of negative 2. You're going to use either an e to the x value that's on your calculator. Usually the e includes that exponent, so you don't have to put in the special hat symbol that you normally would for that. Here's some other examples of how you would put those in.